Now we're going to talk code. So, as a disclaimer, this is not the only way to do this. I am using the Flexcan library because I'm using a Teensy right now. So your code is going to look different no matter what. But your methodology of all the stuff I've talked about in the previous videos should be the same. You should know how to receive all of the components of your response. You should know how to send your response, judging by what gauges you want, basically, from all the stuff I've talked about previously. So I'm going to go through kind of a quick demo of my code here. I am not really an embedded programmer, as you will quickly find out. So a lot of times I'm just using int, right? I'm not using this, so whatever. Complain if you want. But I'm going to explain my process for how I'm using Flexcan and overall how you can use an Arduino to mimic the access port and send your own data and display or log whatever gauges you want. So the first thing I'm going to talk about here is how I'm storing stuff. So I am basically storing things in a global variable. You can sue me about pointers, I don't care. So I basically have a global variable here and it is 61 bytes in length. That is because I am accounting for two types of data logging. I'm accounting for the regular just gauges that I'm displaying all the time. I'm also accounting for if I'm doing a data log on the access port, which holds a lot more stuff. So I want to be able to deal with both with one variable. So that's why it's 61. Otherwise, it would be a lot smaller than that. So that's basically where I'm storing all my stuff, is I'm actually writing the entire response to a single array here. And then I know which indexes inside that array hold the values. And then I can do my calculations on that. I'm also doing a couple things here about how I'm tracking what I'm parsing and stuff like that. I've got my more global variables here. This is basically what I'm storing my final calculation in. So when I calculate what the feedback knock is, I'm actually storing it in this global variable here. Same with these other things. So regardless of whether I'm data logging or I'm just displaying gauges, I'm still only displaying the same data. I'm not changing them, I'm just changing how I look at stuff. So this stuff remains the same no matter what. Then I've got some extra kind of things in here about how I'm doing my super ghetto race car shift lights and whatever. That's just for fun. The next part is when I am sending data. So as you'll see here, I've got two groupings of arrays. And they might look familiar because they are basically access port SSM gauge requests. These are basically exactly what I'm going to see in those spreadsheets I just went over in the previous videos. This is my regular 6 gauge request. So if I send this data, this is exactly what the access port is sending when I'm looking at just 6 gauges on the, basically like the display natively. If I'm doing a data log, I'm actually sending this crazy big grouping of requests. So this is all sorts of stuff. This isn't just the gauges. This is tons of other stuff that I would give to my tuner if I needed to see if something was wrong and stuff like that. So when I do a data log, I'm actually logging all of this stuff, even though I only really care about certain things displaying in front of me, or if I'm putting it over a video and stuff like that. I don't care about AVCS timing, but I'm still logging it and I'm just extracting the stuff out. I'm actually not using this right now. I put it in here, but I'm actually not doing my own data logging right now. I'll actually show you what I'm doing when I actually switch to the access port being turned on. But when I'm using this is when the access port is not plugged in. I am doing this purely on my own, and I am getting the exact same gauges myself as the access port would, and I can make them look however I want. So the other piece to this is I am tying in my oil pressure and temperature sensors that I have added myself. They are AEM gauges that feed into an Arduino. That Arduino then actually measures the voltage and does the calculations, and it actually gives me my pressure and temperature, basically, readings. Now, the Teensy runs at 3 volts and the Arduino runs at 5. So I can't actually just put those sensors straight on the Teensy. I actually kept the Arduino, and what I do is I actually create a serial connection between the Arduino and the Teensy, and I send this data to myself. This was kind of a pain in the butt. I ended up having to use a step down like logic converter to go from 5 volts to 3 volts. And the really annoying part is that everything would work. When everything was plugged in, it would work, and then it wouldn't. And the thing would just like keep rebooting. It drove me crazy. And it turns out it has to do with like having this connected. There needs to be the common ground needs to be there, common power. Like, it was just very frustrating. But when I've got both of these, everything hooked up and everything connected to the same power source, it works. That's all that matters. This stuff here, it's just displaying, right? I'm using a ILI 9341 screen. It's like a 2.8 or whatever inch TFT screen. The good thing about the Teensy is that it's super fast, so I can actually write data to it so quickly that there's no flickering. That's one thing you'll see. If you use an OLED screen on an Arduino, you'll be fine, but it's super small. I'm using a big screen, and the Teensy is so fast that I can update that in real time, and I never get a flickering. And if you've seen a TFT screen on an Arduino or something like that where it's slow, you'll know what I mean by flickering. This thing is rock solid, updates instantly, 0 issues. This little guy right here, this is a union in Arduino terms. I don't know what the heck it really is in C, but whatever. This is how I'm actually converting things into floats and also sometimes integers. So in the previous video, I talked about how if you've got a float, you actually have to basically reverse it and then you turn it into a float. Well, that's kind of easier said than done with C. So I feed it into a union, and whether this is really the right way, no idea, but it works. So what I do is I basically just feed it the 4 bytes in reverse, and I tell it, give me the float value, and it does. Works perfectly. This stuff's just for basically development purposes. It's about printing stuff, whether you want to just print out, like, you can turn this test data to 1 and it'll just generate random stuff if you just have the screens plugged in just to look at stuff. Mostly just for logging. So right now, this is the way I run it, where I run it in what I call active mode, which means I am going to be sending this data by default. There is no access port plugged in. And I'm updating it every 50 milliseconds. So I'm basically running this at 20 hertz. I'm doing 20 requests a second and displaying them. When we look at the setup for the Arduino stuff, it's all pretty straightforward. I've got my serial. This is my, like, if I plug in with USB, this is the serial that I'm using to the Arduino. So the Arduino side is a software serial. This one is a hardware serial because this Teensy is awesome. So that's normal stuff. We've just got some regular stuff for the screens. All of this stuff is just screen stuff, right? Not a big deal. We get into right here. This is where I talked about in one of the very first videos about Flexcan starting up and basically waiting for events. So I'm running at 500K. Everything is normal here. I've got my filter set for 78 and E0, so I'm only capturing AccessPort data or my own. And I basically just say, hey, start listening. When I receive a CAN bus message, I'm going to run this CAN sniff ISO function. That's just setting that up. It starts and then it just kind of waits for 10 seconds before it does anything else. So here is the function. This is really the meat of it all. Every time I receive a CAN bus message, I am running this function here. So there is some stuff in here just for printing, right? If I've got verbose on, I want to print stuff to the serial. I don't need that when I'm running. So this is just, that's normal Arduino code, right? One of the big things about this is that I have a little thing in here that's actually looking for whether a access port is plugged in or not. So as I said before, I've got all of this big thing for data logging, but I don't use it. That's because I'm data logging on the access port. You can't have these both plugged in at the same time, because if you start sending CAN bus SSM messages and the access port is sending them, you're going to get everything out of order, out of whack. The ECU is not going to know what to do, and it's going to probably start doing weird stuff. So what I do here is I actually listen for 7E0 requests. So that basically means if I see somebody else making these requests that I'm doing, I will turn active to 0. So this basically just says stop sending events. So what I'll do is I will just go into pure listen mode. So again, remember that I'm running this function whenever I receive a message on the SSM side. So I don't have to send messages. I can just sit here and listen like I did when I was reverse engineering this. So this code right here, it just listens for whether an access port starts talking, and if it does, I stop and I just listen. But everything else works just fine. So now we're going to talk about how I'm parsing my actual responses like we would see in a spreadsheet. So 78 is going to be the response, obviously. What I'm doing is I'm looking at the very first byte. So this is obviously how I can tell if it's the start of a message, the middle of it, or the end. We just talked about how ISO-TP works. So I know 10 is the start. I basically, this code, I'm not going to get into it too crazy. It's not that hard to listen to or to read. Sorry, you don't listen to code, you read it. I basically take that big array at the top, right? I zero it all out. So I know that if I get a 10, I've got a brand new request. I'm going to start from scratch. I then look at the length of the response. So again, I know exactly what the access port is doing because I've got it here. I'm doing the same stuff. So I know if my response is length 11 hex, I'm doing the 6 gauge mode. I know if my response is 3D, I'm doing a data logging mode. So this basically just says, hey, which mode am I in? And if I don't get one of those, I do a 0 because something went wrong or something changed. So this is how I detect whether the access port, when it's connected, is either just listening with gauges or if it's data logging, because obviously my response changes and I have to parse the data differently because things are going to be in different places. Now, if I don't have any sort of access port connected, it's always going to be 11 because I'm the one sending it. But this block right here is how I'm detecting if something else is connected, what type of response am I getting back? The last piece of the first frame is going to be the actual data bytes. So as we know, the first frame has a little bit of regular information, and then the last 5 bytes of it are the actual data of the response. So I basically just write the last 5 bytes of that response to the beginning of the array. And now we have started and we know we're going to get more messages back. I'm going to go down a little bit further here to the else. So I'm going to go back up because I lied. I'm detecting my first frame. I'm also detecting my flow control frame. As I mentioned in the previous video, if I get a flow control frame back, that means I have seen everything there is to see, and now the ECU is saying, hey, send me the rest of your response. So I have already sent, or the access port has sent a 0x10, which is the beginning frame. And the ECU is saying, I'm ready for the rest of your request. The only way I could be sending my request is if I have received everything. So let's close that out, which means that if I get anything other than a 10 or a 30, it is going to be a 21, a 22. It's going to be a regular part of the response. I also know that since the Teensy is so fast, I am getting everything in order. So all I do is if I just get a regular packet, I'm assuming it's going to be in order. So far it has been. And all I do is I just write every byte of that response to my big array in order. And I'm counting kind of like the positioning, stuff like that. That's kind of how I keep track of where in the response data, which is that big 61 byte array, this is how I'm writing my response to it. So every 21, 22, 23, 24 packet I'm getting, I'm literally just writing it, appending it to this array, if you will. So by the time we're done reading all of this stuff, I've got a big array with all of the values in it in order. All right, so as I just mentioned, a 30 means I have received everything there is to receive. Let's close out this little print here. Now what we're looking at is some checks in here, basically. So if the ECU gives me a 30, but it is not all zeros, so obviously you can have a 30, but you can have some other stuff in there. This is my kind of break out of the loop. So if I don't get if the ECU sends me a 30 with something else in there and just says, hey, you shouldn't be sending me more data, wait, blah, 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 error, I just exit out and I just stop everything. This is just for sanity check to potentially keep it from freaking out the computer. So far, I haven't had an issue with it yet. So this is kind of like how I just know that if I get something other than a 30 with all zeros, I stop. We got some regular prints, blah, 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 the normal stuff. Here is where this display mode comes into play. Remember, up here, I've got my display mode based on whether I'm doing a data log or not. So I've already gone through, I know exactly where things are in my array. Display mode 1 is just a regular 6-gauge one. So what I'm doing is, I know in my array here, you can see I've got these references. Remember, response data is that 61 byte array that holds all of the stuff that I have grabbed. Once I've received my 30, I know that array is full of everything I need. I know exactly where things are because I've done it in those spreadsheets. So all I'm doing here is I'm actually just setting these variables saying, hey, feedback data is the first 4 bytes. And remember, this is a float from that spreadsheet or that XML file, from the ROM Raider stuff. I know that it's a float, which means I have to parse it in reverse. So I actually take 3, 2, 1, 0, right? This is how I'm actually writing this data in reverse. So you can see I'm basically taking all of the values here, I'm storing them in these variables, and the same thing with display mode 2. This means I'm data logging. You can just tell that it's all the same except the positioning changes because I've already mapped all those out. I know exactly where things are. So what ends up happening is these variables are holding the 4 bytes of data we would have seen in those spreadsheets. Now, what you'll notice here is I'm actually storing the final variable after a function. So this is where it gets into those calculations that we were talking about in the previous video. So for example, feedback knock, I don't have to do anything to that actually, I just print it. When we talk about boost, I actually have to do like a multiplication of 0.01, blah, blah, blah. I get this from that XML file from those conversion tables. Same with RPM data. You have to divide it by 4. I multiply it by 0.25, same thing. Same with, if you're talking about DAM, which is also called IAM and stuff. What I've done is I have taken the conversions from that XML file. I have figured out which ones share a common thing. If it's just a multiplication or if it's a division or whatever. Sometimes some of these, like the temperature ones, those share kind of a common formula. But I know what my bytes are. These are in perfect order. I either convert them to a float, I do some multiplications to them. This is just regular code that if you've done any Arduino work or anything like that, any sort of programming, you've got enough now to figure out how to convert this to a real number. Here's an example of what I'm talking about. So my calculate float, I feed it the data and I feed it what I call a multiplier. And all I do is I take that 4 bytes that I've already sent in reverse, so I can read it normally in here. I call that union up top and I turn it into a float. And I basically say, turn these 4 bytes into a float, multiply them by the number I feed it. So for the feedback knock, I feed this a 1. So all I do is I convert it to a float and I'm done, right? If I need to divide or multiply, I can, and that's how I can deal with this on a float basis. Same thing with temperature, right? I've read this from the spreadsheet. I know I have to do this calculation to it. Exactly the same thing you would figure for anything else, right? You know from the previous videos how to look at the bytes you received and how to convert them into what you need. The weirdest thing I've probably had to do was deal with the oil sensors. So since I have to receive those on a serial connection, it's actually probably one of the most annoying things I've had to do is figure out how can I send 2 integers over a serial connection and be able to parse them properly on this side. Again, I am not a embedded or C programmer. If I was doing this in PowerShell, it would take like 2 lines of code. This was a enormous pain in the butt. I have basically found this weird function that somebody did where basically I'm sending the values with like an A and a B after them. And this code, which I found on the internet, on Stack Overflow or whatever, who knows how it works? All I can tell you is that this basically splits that string in 2 and turns it into an integer, and then I can do work with it. Very big pain in the butt. If you know how to send 2 separate integers over serial and receive them as 2 separate integers, please tell me, because while this works, it's ugly. Okay, I just talked about what happens when I receive a message. Since this was set up in the setup function, this is happening no matter what. This is why I can have the access port plugged in, this thing not sending messages, since it would detect that, and it would still work and do exactly what it's supposed to do, display me my gauges, all of that good stuff. What happens when the access port is not plugged in? So I'm actually not getting any data, and since we're starting with active equals 1, we go down to our loop here. First of all, this is where I'm receiving the data from the Arduino, the oil data. Again, somebody please tell me how to do this better because I don't like it. Here is where I'm telling it what to do. So if active is still set, that means I have not seen the access port show up. I am going to run this function send request. The rest of the stuff in here is assuming that everything is working properly. So one thing I'm also doing is right here, you're seeing where I set my kind of mins and maxes. This is just kind of mimicking what the access port can do. I'm tracking the feedback knock. I'm tracking kind of the fine knock, right? And I'm saying, what were the maximums I saw? Just so I know it's not absolutely freaking out. This is the function right here that actually prints the data. So you can see I'm sending it like a row, like a number above, where to write it, what the values are. This again, this will be different depending on what type of controller you use. Since I'm using a Teensy with a very fast controller, I'm using what's called a frame buffer. And that's why this writes so fast. But in the end, all I'm doing is every time I loop, I am actually assuming the variables are set. Because every time we hit the can sniff, I'm actually, once I see a message at the end, I'm just starting over again. So all of these global variables are going to always hold the last value. So I won't get into a situation where like one of them is nothing. They're always going to have something in them from the last value, and when they get updated, they get updated. So that's why I can loop through here and print the values over and over again, no matter how fast I'm getting anything else back. You can see at the bottom here, again, this is how fast I'm updating. Also how fast I'm sending. So this can be changed if I want to slow things down, if I'm logging or debugging stuff. But again, right now I'm sending basically 20 requests a second. Now, the real fun part is how am I mimicking the access port? So as you can see here, every one of these loops, if I'm active and if flow cont is still enabled, this means I have been getting 30s with all zeros back, as we saw in the function above. If I do not get a good flow control back, this turns off and then I stop sending events. So let's go take a look at this function. Here it is. It's pretty simple actually. I send my first request, which if we go up here, request 1 is my 10. I'm telling it I'm giving you 35 hex. I am doing an A8 command, which is a read. Here's my padding. Here are the rest of the, start feeding the memory addresses, right? There it is. So I send my first request. The ECU is then going to send me a flow control back. It's going to send me a 0x30. Assumingly, it's going to have all zeros in it. I'm not checking for that. So there are some implementations that can actually do ISO-TP natively. I didn't get them to work. I didn't care. I wrote my kind of own. I'm just doing it the ghetto way here. So I'm sending, I'll type it in here, 0x10. The ECU responds with 30, assumption. I then send the rest of my rows, 2 through 8, all at once. When that's done, I have another delay in here because the ECU is sending me their 0x10 response first packet. Now the ECU is waiting for me to tell them to continue. I need to send my own flow control 0x30 telling it to go. Here's my flow. I just sent it a 0x30. Here's the code that just sends it the regular data. Again, there's nothing fancy about this. It just writes the message. So this is it. This is all you really need to do to be able to send these messages. Now you've done a lot of work to come up with what this means. This requires a lot of, effort to get it to work right, so you know what memory addresses you want. At the same time, when you're parsing the results, this stuff matters too, because you need to know where your response is, you need to know what the math does. But in the end, it's still not a whole lot of lines of code to send this messages. I send my first one, I give it a little bit of a delay for the ECU to say continue. I send the rest of my message. The ECU then gives me their start of the response of 0x10. I wait for that to happen, assuming it takes 10 milliseconds. I then send my flow control saying, here's my 0x30, give me the rest of your response, and it does. Loops through that over and over and over again. And while it does that, I am printing the values with this right here. And there you have it. That is how Arduino code can do exactly what a cob access port can. You can data log with this. You can do whatever gauges you want. It's all up to your imagination. I'm not going to necessarily get into like the print because honestly, I can just show you a picture. Me printing stuff doesn't matter. If you can print this to the serial monitor, that's like, frankly, like this right here. If you can do that, you are golden. Figure out what you want your screen to look like and make it happen, But yeah, this is the code I am using right now. I'll upload this to GitHub and it's in its current terrible form. One of these days I will stop being lazy and I will convert all the definitions to where they should be in true Arduino fashion. But this is it. This is the code that runs. And I'm going to next post kind of like what it looks like when you actually like upload it to the Teensy or whatever you're going to use and hooking it all together. And we're going to see what the data looks like on the vehicle with all of the stuff put together.